Welcome to the explainer. So, what if you could search, compare, and just transform text, no matter how huge it gets, and do it in linear time? Well, today, that's exactly what we're going to do. We're building the ultimate programmer's toolbox for tackling pretty much any string problem you can think of. All right, so here's the deal. We're going to break down 10 incredibly powerful patterns. And look, these aren't just some abstract theories you read in a textbook. These are the real deal techniques that turn those hairy, complex text problems into, well, elegant and super efficient solutions. And yeah, when we say linear time, we mean fast, like solutions that don't even break a sweat as your data gets bigger and bigger. Okay, first things first, let's get our toolbox stocked up with the 3 most versatile patterns out there. Seriously, these are the ones you're going to be reaching for all the time. They're the absolute foundation for your string manipulation skills. And here they are, sliding window, 2 pointers, and hashing. You got to think of these as the screwdrivers and wrenches of your algorithm toolkit. They're simple on the surface, right? But they are so incredibly powerful and pop up in a huge range of problems. So the sliding window, this is such a cool technique. Just picture a ruler sliding along your text, you know? The right side of the ruler keeps expanding to grab new characters, while the left side shrinks just enough to keep some rule valid, like say, no repeating characters allowed in this window. This constant back and forth lets you solve really tricky substring problems in just one single pass. That's what that ON complexity means. It is crazy efficient. Next up, 2 pointers. Its power is really in its simplicity. I mean, just imagine you're pinching a string with 2 fingers, one at the start, one at the end. Then you just move them towards the middle. That's it. That's that monotonic movement. As they meet, you can check for all sorts of things, like if the string is a palindrome, and you do it in linear time. It's all about using the structure that's already there in the problem. And this one, hashing and frequency maps, it's literally just about keeping score. Think of a scoreboard, right? With a little slot for every letter of the alphabet. As you scan through a string, you just add a tally mark for each character you see. That's it. This super simple counting trick is the key to solving problems like finding anagrams inside a bigger string, all in one shot. All right, so we've got our basic tools down. Now let's bring out the heavy machinery. These next patterns are your power drills and scanners. They're for high-speed search, for finding that one tiny needle in a massive digital haystack, like instantly. So we've got 2 main categories here. On one hand, we've got tools for finding just one specific pattern, but with incredible speed. And on the other hand, we have these even more advanced tools for when you need to find a whole dictionary's worth of words at the same time without slowing down at all. So let's look at these 3. They're all ridiculously fast, but they get there in different ways. You've got KMP and the Z algorithm, which are smart. They pre-process the pattern so they can make these huge intelligent jumps when they find a mismatch. They give you a solid worst-case guarantee. Then you have Rab and Karp, which uses this really clever fingerprinting trick with hashing. It's usually lightning fast, but it works on averages. Now, if you're searching for a bunch of patterns at once, a trie is a fantastic place to start. It works like a digital dictionary, right? Perfect for something like autocomplete. But a Hokarsik, whoa, it takes that to a whole new level. It basically builds a trie, but then adds these failure links. You can think of them like little shortcuts or safety nets. They let you scan a text and find every single word from your dictionary, all in one clean pass. It's amazing. Okay, time for the precision instruments. These next 2 algorithms are just beautiful. They're designed to solve very specific but very important problems with absolute perfect efficiency. These are your specialty tools for when the job has to be done just right. So, finding the longest palindrome sounds kind of tricky, right? Well, Manneker's algorithm nails it in linear time. It is a total masterclass in exploiting symmetry. It cleverly expands around possible centers, but here's the genius part. It remembers the palindromes it's already seen and reuses that information to skip massive chunks of the string. No redundant checks at all. Edit distance. This is the classic algorithm behind basically every spell checker or diff tool you've ever used. It uses a technique called dynamic programming to figure out the distance between 2 words. The way it works is by building up the solution piece by piece, you know? It solves all the tiny subproblems first, like the distance between shorter bits of the words, and uses those answers to build up to the final one. Let's actually walk through how it works. So first, you imagine a grid. You put one string along the top and the other down the side. Now, each little box in that grid is going to hold the cost, the number of edits, to get the prefixes to match up to that point. You fill it out, cell by just looking at your neighbors. which tell you the cost of an insertion, a deletion, or a substitution. Once the whole grid is filled, the number in the bottom right corner, that's your answer. That's the minimum edit distance.
Okay, so we've filled our toolbox with 10 seriously powerful patterns. But here's the thing. The final skill, and honestly, the most important one, is building that intuition, knowing exactly which tool to grab for which job.
So just remember these 4 big ideas. First, always assume a linear time solution might be out there. A lot of the time, one of these clever patterns can get you there. Second, pre-processing your search pattern like KMP does is a fantastic strategy that can save you a ton of work later. Third, if you're hunting for a whole bunch of words at once, your brain should immediately go to tries and automata. And finally, if the problem feels like it's about similarity or transforming one thing into another, dynamic programming is going to be your best friend. But really, it all comes down to this. The key isn't just memorizing a list of algorithms. It's about recognizing the structure of the problem itself. Before you even write a line of code, just stop and think for a second. What kind of problem is this? Is it a constrained substring, a single pattern search, a dictionary lookup? If you can identify that underlying structure, it'll point you to the perfect tool every single time.
So now your toolbox is officially stocked with these 10 essential patterns. The only question left is, what challenge are you going to solve first? Thanks for watching.